Okay, today we'll be starting section 6.1. We're going to be computing probabilities using the probability distribution of these discrete random variables. We'll talk about that phrase in just a little bit, and then we'll move on to calculating and interpreting the mean, also called the expected value of these discrete random variables. Okay, so this starts on page 347. If you haven't read this page yet, I want you to pause now and read all the way through to the bottom. And if you have time, also read the intro over here, okay? Pause and read. Okay, if you're asked to create a sample space for this or of all the possible outcomes, a little tree diagram could help, okay? Because then you can follow these, right? 3 heads, there's 1 strand, another strand has 2 heads and a tail, and then you keep going to create all these strands in the sample space. Okay, so they're defining the variable x to be the number of heads obtained. We could have 0 heads, 1, 2, or 3. Those are the outcomes, right? There's no other, when you're counting the number of heads, that's the possibilities. These are actually called discrete numbers. We'll get to that. So 1/8 chance of 0 heads, also 1/8 chance of 3 heads. And then we got 3/8 for the other 2 scenarios. Okay, so now we have this probability distribution. Okay, so what's the probability we get at least 1 head in 3 tosses? I might be going a little too fast. Pause and write that down if you need to. But at least 1 would be this, 2 heads, 3 heads. Add those together, or we can do 1 minus none. 1 minus the 1/8 gives us 7/8, okay? All right, so a random variable is any type of random outcome through some chance process. So in this case, it was the number of heads. That was the random variable. We could also define it as the number of tails, okay? That takes on numerical values. All right, so that leads us right into the difference of discrete versus continuous. Continuous are going to be numbers that have multiple decimals. Like there's many ways we can measure height, 6.01 feet, 6.12 feet, and so on and so on and so on. So a lot of times we want to use the normal distribution for continuous, but discrete is going to have gaps. Like we can't say the number of heads that happened in 3 tosses was 2.1 or 2.2. It doesn't make sense. So when we have these gaps in the numbers, they're called discrete, okay? They said they have fixed set of possible values. These are definitely fixed, right? We can't get anything other than 0 through 3, and there's gaps between them. It's not always integers. So you could have some decimals like shoe sizes are a good example, because we could have, right, 1.52, 2.53, 3.5. There's still gaps with decimals. Okay. Excuse me. All right, so we've seen this before. To make these probabilities legit, these are the requirements. Each individual probability has this range between 0 and 1, and then the sum is 1. All right, so in this example, pause to read up on it if you need to. I'm going to continue on. Show that the probability distribution for x is legitimate. Okay, the sum is equal to 1. I already added these up for us. So we take all these, add them up. It does equal 1. Okay, and every individual probability, if we analyze it, is between 0 and 1. Okay. All right, then we stop at 9 because apparently in that season of 2010, nobody scored more than 9 goals. All right. Okay, let's turn the page. B says make a histogram. It's already made for us over here, but let's just review this because you are going to have to make 1 or 2 in your OTI. You know, whatever the discrete outcomes are, put that down here, your goals. And then you just do the height of the frequency. All right. 0 goals happen 6% of the time. Okay. I know it's probability, but we can also call it frequency. 1 goal happens 16% of the time. This is from the previous page, and so on. Just draw the appropriate heights to the appropriate number of goals. All right, so when it says describe what you see, that kicks in the 4 components we got to remember, right, from CUS. What's the center? Well, 50th percentile is the center, so we can use these numbers to our advantage. So if we start doing some math and adding this up, if I add these 3 numbers together, it gives me 0.45. So I'm not quite at the 50th percentile. It must be in this, because when I add 45 to this height, it gives me 0.68. Okay, so the 50th percentile must be with the 3 goals bar. So that's the center. The center is 3. There's no gaps in this histogram, okay? So there's no apparent outliers. It definitely is slightly skewed right. This tail extends a little bit. And then we don't know the standard deviation. So spread, we prefer the standard deviation when we have it, or interquartile range. But we don't have that information right now. So we're just going to talk about the spread of the goals ranging from 0 to 9, okay? Okay, what's the probability that the number of goals scored by a randomly selected team in a randomly selected game is at least 6? At least 6 does mean we include 6. So we flip the page over and grab all these numbers from the distribution. So 6, that was 7, that was the 8, that was the 9. Add them up, we get 0.061. All right, so with context, we would have about a 6.1% chance of selecting a team with at least 6 goals scored. All right, after you write that down, I want you to pause and try example 3. It's your turn. Just a heads up on this too. It says A is a 4-point, right? They're using the 4-point scale. So that's kind of what this means. This is the probability of an A, this is the probability of a B, and so on. Okay, pause and try that, then we'll go over it. Okay, the meaning of X greater than or equal to 3. It's the probability of a student at this institution selected at random of having a B or higher. Okay, and then they said find it, 0.68. It says write the event. The student got a grade worse than a C in terms of values of the random variable X. They want you to use this notation. So you can say less than 2, okay, because a grade worse than a C doesn't include a C. Worse than a C would be a D or an E. So we can write that as less than 2, or you could say less than or equal to 1. Experience with inequalities, that should make sense, but these are both okay in this discrete style. So there's the answer, 0.12. And then C, once again, they made the histogram for you. You're going to have to make one later, though. Center is at 3. Okay, 50th percentile lies here. No apparent outliers. This is skewed left. Values range from 0 to 4. Okay. All right, let's turn the page. I want you to read this setting here. I'm going to pause it to let you do that. Read what's going on with this next learning target first. And example 4. Okay, I don't know if you've ever seen a roulette wheel, but it looks like this. It's in your book. It's a gambling wheel. It's pretty much any casino. And at first look, it looks like, it's all black and red. But then they throw in these 2 green numbers to tilt the odds to their favor. Okay? But the black and red numbers go from 1 to 36. So basically, this is what's going on here, right? I got 1 to 36. So all these 36 numbers, 18 are red and 18 are black. Okay? But then they throw in these 2 green numbers. So the probability of you getting your red bet, if it was a 50-50 outcome, would just be 18 out of 36. But we have these 2 additional outcomes. So it's actually 18 out of 38. All right. And then probability of not red, I'll put RC, will be equal to, now you got 20 outcomes that are not red, right? The 18 black and the 2 green. So it's 20 out of 38. So right there you can see throws the odds to the favor of the casino. And of course, they've got to make money, right? I think this works out to somewhere around 47% of the time, and this one works out to around 53% of the time that you lose. All right, so what are the possible values of X? They called X the net gain. Net means what you walk away with. Okay, so X could either be you lose that buck that you put on the table, or they match that dollar. Okay, so you walk away with 2, but your net gain is just $1. So either you lose $1 or you gain $1. Okay, here's the corresponding probabilities that I just explained in this game. And here's what it looks like as a distribution. I recommend you write this down. You got to start learn how to make these. So X is the random outcome, either a negative $1 or a positive $1. And then here's the associated probabilities. Okay, so what it makes sense to do here to find the mean is do this, right? If we make $1 only about 47% of the time, then we should multiply 47% times 1. and then we lose $1 the other 53% of the time. So you multiply. Once you add that together, that gives you the mean. Okay, obviously you don't get -5 cents just from playing it once. This means in the long run, your long run average. Okay, for every dollar you play in the long run, you're going to lose 5 cents. Okay, so here's the interpretation for part E. In the long run, or you could say after playing this many, many times, thousands of times, the player will lose an average of 5 cents for every $1 bet they have. Okay, so that dollar continues to diminish, right? In the long run. All right, so that's actually kind of a formula that we're going to use now for expected value. I'm going too fast, pause, and catch up. Okay, this formula is on your yellow packet. Let me show you the spots right by our probability stuff because we got these probability rules, and then here it is. Here's the third one. The capital E means expected value of X, and they also put mu of X, right? Average for this X random variable. This means sum of these products of X times P, because that's what we did here, right? We did X times P, and then we added X times P. Okay, that's the process. That's written out long way, but this is the short way to do that. Okay. All right, so last example, let me walk you through here. This is the earlier example about the number of goals scored by a randomly selected team and a randomly selected game. Okay. All right, so compute the mean of the random variable X. So what is the average goals? It's basically what we're looking for. What was the average goals? All right, so here we go. Why don't you write this down? Sigma, or sum of X times P. So I take 0 times the 0.061. Obviously, that's going to be 0, but you got to show your work. Okay, so just get this started. I know there's a lot of sums. You can shortcut this, and this is how you can shortcut it. Do it again. Go to the next one. 1 goal times 0.154. All right, and then just put plus ... and let's just end with the last one, the 9 times the 0.001. Okay. All right, let me show you how we can find this in the calculator. Okay. Hopefully you have a graphing calculator you can be using and get your hands on. All right, I'm going to pause to do this as well, but let me show you the first set of directions because I want to squeeze this in 15 minutes. You go to edits, so stats, edit, that button there. And then we're going to put it in our L1 and L2. L1 is going to be the goals, and then L2 is frequency. Okay, pause to plug that in there. All right, so here we go. Stat edits, put these in here. And then this is how you calculate the mean. Okay, so I go to stat again. I go to calculate. Now you do want one variable statistics. Some get confused because we put in 2 rows. It's 2 variable. It's not. This is just the frequency. Our one variable is the number of goals. That's it. So we want to hit one variable statistics, but you need to tell the calculator where the frequency is. I know it says probability here, but it makes sense to call this frequency, right? One goal happened 15.4% of the time. So make sure you punch in L2, or second number 2, for that. And then you calculate, and we end up with our average right here, top line. There's some other things here we'll use later, but for now, 2.851 is our average number of goals. Okay, so here's the interpretation. In the long run, or after selecting many of these teams, the average number of goals scored is 2.851 goals. Okay. All right, that's it for today. Have a good day, and I'll talk to you soon.